Hello. Today we're going to learn how to balance chemical equations. Now, in past classes, perhaps the teacher just told you to balance the chemical equations and didn't really give you any instruction or strategy on how to get that done. And you probably used what I would call the guess and check method, and it was somewhat frustrating. So I'll give you some simple rules, and hopefully by applying these rules, you'll be able to balance any equation in under 30 seconds. So in my first example here, I'm showing an unbalanced chemical equation. If we assume what's on the left side of the teeter-totter are the reactants, and on the right side the products, we have more reactant than product. And we know that violates the law of conservation of mass, so that couldn't happen. So here's what the equation represents. H2 plus Cl2 goes to HCl. That's the chemical reaction we want to deal with. Now, when looking at that, on the reactant side, I have two hydrogens and I have two chlorines. But on the product side, I have only one hydrogen and one chlorine. So that's clearly unbalanced. So the way we're going to fix this is not add a subscript 2 down here and 2 down here, right? Because then we don't have HCl. We have some other product that is not allowed. So instead of using a subscript, we're going to add a coefficient. And so here's what it's going to look like. It's now balanced. The atoms have been rearranged, which is what happens during a chemical equation. Now, this coefficient 2 in front of the HCl indicates you have two separate HCl molecules. Now, on the reactant side, we have two hydrogens and we have two chlorines. On the product side, we have two hydrogens and we have two chlorines. So it's balanced. Now, I don't think you want to be writing out and drawing equations with little teeter-totters. That's going to be too much work. So we're going to come up with a different way to do this. Okay? I want to make sure before we proceed, though, that we know the difference between a coefficient and a subscript. So in my first example here, H2O, that's representing a single molecule of water composed of two hydrogen atoms and one oxygen atom. In the next example, I have two separate water molecules composed of a total of 4 hydrogens and 2 oxygens. And in the last example, I'm using, well, look at this. This is one giant molecule composed of 2 hydrogens and 2 oxygens. So we would call that H2O2. There's one of them, and that molecule is called hydrogen peroxide. So hopefully we can see that coefficients, numbers written in front, and subscripts written below don't mean the same thing. When balancing a chemical equation, you are not allowed to add any subscripts. You can only add coefficients. So let's get started. These are my rules. I'm not sure you're going to find them in any textbook, but I'm going to make the claim that if you use these rules properly, you can balance any equation in under 30 seconds. And there's not a lot of rules. We just need to know how to use them. Now, the first rule says guess and check. Well, I already told you guess and check is not a strategy. So let's get rid of that. Forget about that. Instead, when balancing an equation, what you want to do is go to the most complicated looking thing first. Now, that's not always the way you want to solve it. Look, in the real world, if you have a lot of things to get done, and some of them you enjoy doing and others you don't enjoy doing, my recommendation would be do the stuff you don't want to get done first, because you'll have a little bit more energy. And then when you're tired, you might have more work to do, but you're going to be doing stuff that you want to do at the end. So for us, we're going to deal with anything that contains a polyatomic ion first. It'll tend to be the most complicated. Now, here's an example of an unbalanced chemical equation. The lines in front are going to be where we're going to add our coefficients. Now, when I look at that, anytime you see parentheses, that's a giant red flag. See there, we have 2 ammonium ions. That's where I'm going to start. So it's important to understand that this coefficient, or excuse me, this subscript 2 right here is for whatever's immediately preceding it, which in this case are the parentheses. So there's two NH4s. Well, when I look over on the product side, I see only one NH4. So I'm going to put a coefficient 2 there, and that is going to take care of the ammonium. Now I have two NH4s on the product side, two NH4s on the reactant side. Now I'm sort of going to be like a cat chasing my own tail. So what I mean by that is if I have two NH4s, well, I also have two BRs. So now I go over to the reactant side and I have two BRs. Then I have one SR on the reactant side and I have one SR on the product side. I have one carbonate, CO3, on the product side, and I have one carbonate on the reactant side. It's not necessary to put coefficients 1 in front of these. You can just leave those off. It would be understood. Okay? I'm going to go ahead and if you want to leave them on yours, that's fine. I'm going to go ahead and erase them from mine because, as I said, they're not necessary. At this point, that equation is balanced. All right. So if you try the polyatomic ions first, it's really going to help you get a lot of things balanced quickly. The next rule, well, I'm going to call it the final rule. There might be some others, but do single elements last. Now, you're like, but they're the easiest things to do. Remember we said easiest things should be done last. And I'll show you a little trick at the end to clean up single elements. Then we have what I call the even-odd rule. If you have an even number of atoms on one side and an odd on the other, there's nothing you can multiply an even number by to make it odd, but you could easily make an odd number even. Let's look at an example, and it will also contain polyatomic ions. So in this example, I hope what you see first is the polyatomic ions. You have two nitrates here, and you have three nitrates here, indicated by the subscript outside the parentheses. So we need to deal with this first. Those are the polyatomics. So 2 is an even number, 3 is an odd number. The number they have in common is 6. So I need 6 nitrates for both of these. So that means this first one has a coefficient of 3. That gives me 3 times 2 nitrates, 6 nitrates. And on the product side, because I have 3 nitrates, I would need to multiply that by 2. 2 times 3 nitrates is now 6 nitrates. At this point, you're going to be kind of like a cat chasing your tail. You have 2 aluminums on the product side, and so we can go ahead and put a coefficient 2 in front of the aluminum. And of course, we have 3 leads on the reactant side, so we'll put a 3 in front of the lead. Then you want to look at it, can that be reduced? Well, the numbers 2, 3, 2, 3 cannot be reduced. So that one, we are done balancing as well. All right. So the even-odd rule is going to be your first rule if there are no polyatomic ions. Okay? Let's look at this one here. N2 plus O2 goes to N2O5. See how there's no polyatomic ions? So the first rule doesn't really apply. And now I just sort of go through and look. I start on the right and just move across. I have 2 N's on the reactant side, 2 N's on the product. Well, that's okay. I have 2 oxygens on the reactant side, 5 on the product side. Well, that's an even-odd situation. What number do 2 and 5 have in common? Well, 10. That means I'm going to go ahead and put a coefficient 5 here. That gives me 10 oxygen. And I'm going to need a 2 over here. And now I have 10 oxygens on the product side. Well, that caused me a little bit of a problem because now I have 4 nitrogens on the product side, but I can quickly figure that out by adding a 2 in front of the nitrogen on the reactant side. Now I have 4 nitrogen and 10 oxygen. 4 nitrogen and 10 oxygen. So it's balanced, and you can't reduce the numbers 2, 5, and 2. All right, single elements last, we'll kind of look at that separately. But let's try one more even odd one. So now some of you are looking at this and saying, well, I see a polyatomic chlorate over here, but I don't see a chlorate over here. Well, sometimes that happens. They're rearranged. So then that first rule doesn't really apply because we don't have the same polyatomic on both sides. So now we're looking for even odd combinations. 1 Na, 1 Na, 1 Cl, 1 Cl, 3 oxygens, 2 oxygens. Well, that's an even odd situation. What number do 3 and 2 have in common? 6. So that means I need a coefficient 2 in front here on the reactant side and a 3 in front of the oxygens. Now I have 6 oxygens on the product side, 6 oxygens on the reactant side. But it gave me 2 sodiums and 2 chlorines and only have 1 here, but I can fix that easily by adding a coefficient 2. So this one's balanced with the coefficients 2, 2, and 3. All right, let's keep looking here. I'm hoping this makes sense to you. You're going to get some practice with this for homework tonight. Here's a couple more rules that aren't always necessary. Basically, these rules that I've shown you here, these 3 rules, will work for pretty much everything. But I'm going to add a couple more little things that might be helpful for you. Here they are. If you balance specifically a hydrocarbon that has combustion, so that means the only thing that we're going to see are carbon, hydrogen, and oxygen. I want you to balance them in this order: carbon first, then hydrogen, and oxygen last. Let's look at an example. So here we have a chemical called propane. It's what you would cook maybe if you're grilling hot dogs or hamburgers in the summer. C3H8. And we burn that with oxygen, and if it has complete combustion, we will produce carbon dioxide and, well, this should say water, not hydrogen gas there. That's clearly a typo. Water. Okay. Now, in order to balance this, we said carbons first. I have 3 carbons on the reactant side and only 1 on the product, so I'll go ahead and put a 3 there. Next, I'm going to look at my hydrogen. It says I have 8 hydrogens on the reactant side and I have only 2 on the product side, so I'll put a coefficient of a 4 there. That gives me 8 hydrogen, excuse me. My brain is already onto the oxygen. Now, on the reactant side, I have only 2 oxygen. On the product side, I have 3 times 2, that's 6, plus 4 more is 10 oxygens. And I have only 2 here, so I need a coefficient of a 5 there, shouldn't I? Let's make that a 5. I don't like that 3 there. So now I have 10 oxygen, because 3 times 2 here is 6 oxygen. 4 times 1 here is 4 oxygen. So I got 10 oxygen on both sides now. All right, let's try another one. This one's going to be a little bit trickier. This one is called butane. It's another gas. It would be maybe in your lighter. If your uncle smokes cigarettes, he might have a little Zippo lighter that uses butane. So C4H10 plus O2 goes to CO2 plus, and then somehow I forgot to make this water and I wrote it as hydrogen again, but it's always going to be carbon dioxide and water. So let's do carbon first. 4 carbons, I need a coefficient 4 right here. I now go to hydrogen. 10 hydrogens, I need to put a 5 times 2 makes 10. Now deal with oxygen. On the product side, I have 8 oxygen here, plus 5 is 13 oxygens. And I need, this is a 2. Well, here's where a little special trick comes in. I'm going to multiply that by 13 halves. Now, 13 halves times 2 is 13. At that point, it's balanced, but we know we can't have halves of molecules. So here's how we fix it. Multiply the entire equation by 2. And when you do that, now let's distribute that, we will end up with 2C4H10 plus 13O2 plus 8CO2 goes to 10 water. And that is a balanced chemical equation. You cannot reduce the numbers 2, 13, 8, and 10. Now, if you were trying the guess and check method on that, it would take you a very, very, very long time to get that answer. Okay? All right. Now, again, you don't have to use that little technique very often, but this multiplying by 13 halves here to get 13, that's why if you save a single element to the end, you can always get that one figured out by using that little special trick. Okay? All right. I'm going to give you one more little thing. I know you're going, well, why did you number it 1, 2, 3, 5? Well, they're my rules. I can number them any way I want, right? Let's try this one. This is a special rule. It applies when nothing else works and you have a hydroxide on one side of the equation and water on the other. Okay? So it's a very special circumstance. So let's pretend that we've been struggling to balance this equation. And perhaps you would get this balance without this rule. Great, then it doesn't apply. It says applies only when nothing else works. Well, what we're going to do is we're going to rewrite water, H2O, as HOH. Now, it looks like I have two OHs on the reactant side and I have one OH on the product side. Well, to fix that, I'm going to go ahead and put a coefficient 2 there. Now, let's see where this has taken me. On the reactant side, I have one magnesium. On the product side, one magnesium. On the reactant side, 2 oxygens, because that 2 goes for whatever's before it, 2 oxygens. And over here, I have 2 oxygens on the product side. I have 2 hydrogens here, plus 1 is 3. But over here, I have 4 hydrogens, so that's a problem. Well, I also noticed that I have 2 Cls and 1 Cl, so I'm going to fix that by putting a coefficient 2 in front. That took care of my chlorines, and it also helped with the hydrogens. Now I have 2 hydrogens, plus 2 is 4, and I have 4 over here. So that one's balanced with the coefficients 1, 2, 1, 2. All right. Hopefully these simple little rules, if you apply them, will help you figure these out. Now, when I say it takes no longer than 30 seconds, that's simply a guesstimate, right? It might take you 45 seconds, but it should not be taking you 15 minutes or even 5 minutes to solve one of these. If it takes more than a minute or two, you're missing something. You've overlooked something. My advice is walk away, work on something else, and come back in a couple minutes, and then I bet you'll be able to get it in under 30 seconds. All right, well, there's some problems. It's the balancing chemical equation sheet. Don't worry about classifying yet. This whole classifying, we're going to do this in the next video. So at this point, we're simply balancing equations. So you see there's a whole bunch of these for you to do, 36 of them, in fact. It really shouldn't take more than about 15 or 20 minutes to get all of those done.